Okay, so Mr. Amado, yesterday we completed till up to STP introduction, right? The basic introduction, the how STP works, right?
Yes, yes.
Okay, so we also came to know that STP is not in use nowadays. Nowadays, per VLAN STP is working. Per VLAN STP like it's supported
Plus,
after 12.4 version of iOS. Okay, means STP is not working. STP used for single instance, but now you have, if you have 10 VLAN, you will have 10 STP, right?
yes,
Okay, so when we are talking about building the STP topology is a multiple convergence process. So STP switches exchange means like how convergence process are working. So whenever they are converging some information, so they are converging the information with the help of BPDU, or you can say that they are exchanging information with the help of BPDU, right? And you can see here when we have some switches here. So if switches are, some ports are in working condition and some ports are in block condition, so these comes under STP convergence process. And these blocking, running condition, everything is working with the help of BPDU, because they exchange BPDU information. And whoever have the superior BPDU, means whoever have the better BPDU, will become the root, right? Okay,
yes.
so STP switches exchange bridge protocol data unit the build to build the topology database or switching topology. Okay, so
Okay,
BPDU are forward out of all ports, all, or you can say all Cisco switches ports in every 2 seconds. Okay, to a dedicated MAC address, because this BPDU is sent to other switches with the help of multicast MAC address, and this is the multicast MAC address. Okay, see in the switching there are, you will find multiple type of like messages, right? VTP message will be
yes,
there, some kind of trunk tagging message will be there, CDP message will be there. Okay, so each and every type of messages use different type of multicast address, same like REP, IGRP, OSPF, right? So if
okay,
this switch
yes,
is sending some information regarding BPDU, then how I will understand that okay, this is regarding BPDU? So they use same multicast address to understand the messages. Now, building the STP topology is a multi-step convergence process. Of course, yes, we know this one. And how it is a multi-step
yes,
converge like a step process. This root switch will be elected when you are configuring or connecting multiple switches together, right? So the first of all root switch will be
yes,
elected. After that, root ports will be identified, designated ports will be identified, and the block ports will be identified, right? And why the block ports will
yes.
be identified in your switching network? To
With,
eliminate the loops in your network, right? So first of all they
yes,
will select root switch, then they will select designated port, and then they will select root port and blocking. Okay, but we will
okay,
see the other why this is a root switch, why not this one. Okay,
yes,
we'll see these things. Okay, note, STP is enabled by default in all the Cisco switches. Okay, now there are some STP enhancements, so the new enhancements came in STP. Okay, so enhanced STP is running, you can say like you will find per VLAN, remember, as
yes,
per VLAN,
yes,
which is known as PVST and
yes,
PVST plus. We'll discuss more about this PVST and PVST plus after some slides. Okay, now the first is root bridge selection process. So if I right now I told you that how this switch is root, now why not this one? Okay, now
okay,
so why root bridge is selected? First understand why why we need root bridge in our network, and then we will come to know
yeah,
why this one is elected as a
it's
root switch.
selected.
So root switch is used to become a transit point of your network. Means if anyone is crossing from your network, or if anyone is passing from your network, so your switch need to working as a root switch. Means if you are passing to communicate to anyone, your data must pass from me. So okay, so I'll be the transit point. Okay. Now, most
Okay.
important switch in layer 2 topology, most important means, and why most important? Because each and every traffic will pass from this, and this root switch will know about your network topology.
Yes.
And if you are configuring root switch, so try to make root switch with the, like, the strongest one. Now, root switch all ports will be in the forwarding state. Of course, we will see this one. Okay. Now, if you want to see, then if you can come here, suppose I have two switches here. Okay. So maybe one switch will be acting as a root. Okay. So let's see who is acting as a root, switch 1 or switch 2. So if I'm coming on switch 1, so a spanning tree, this is root, right? Okay. So if this switch is root, so what is saying that all ports of this root switch will be working in a forwarding state. Okay, no problem. Come here. Now see, I have these ports, and all these ports are working in forwarding states. You can see here, state is forwarding, 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 like that, right? But if I'm coming to switch 2, okay, and if I'm typing here, so a spanning tree, and now if you're coming to switch 2, which is non-root switch, okay, see here, the switch 2 ports are in different roles is different, and you can say the states is different, right? Forwarding, and one is block. Okay, so here what I told you, that if we are comparing with the ports, right, what I told you, that
Okay.
all your switching ports will be acting in, okay, so we verified that all the ports of this root switch will be working in the forwarding states, and always it will be working on the top of the spanning tree, mean it will be as a head of the spanning tree. Okay, and all the link cost calculation starts from root switch. Whenever you want to calculate the link cost to reach from source to destination, or maybe like if I want to reach from non root switch to root switch, so there are some kind of cost calculation.
Okay.
Okay, so that cost calculation is working through this. Mhm. Your this My sound is coming back to me, I don't know why. Okay, so here is saying that the all link cost calculation start from root switch. So I think we have discussed about some cost calculation, because whenever non-root switch wants to reach root switch, so they calculate some kind of distance. Okay, so those distance are known as cost. Okay, so these cost calculations will be decided or sent to non-root switches by root switch, means the calculation is via root switch. Okay, now, and it generate bpdu. So root switch, if I'm talking about stp, okay, so in stp, okay, so here what I wanted to say, that the bpdu message is generated by root switch only. But in which condition? If you are running only single instance, so if you are using stp only, at that time root switch was only responsible for sending bpdu. But when we are using per VLAN stp, these new technology, the enhanced stp, at that time non root switch is also sending bpdu, and root switch is also sending bpdu. Okay, now, so now the other process will question will come, that okay, how root switches are elected. So root bridge election process will come to know here. Now, a root bridge is elected on the basis of bridge ID, which depends on the following two parameters according to the 802.1b format. Okay, so here you have only two conditions to select the root switch, or you can say root bridge or root switch. So there are two parameters. One is bridge priority, or you can say switch priority, which is of 16-bit, or you can say second one is switch or system MAC address. So the collection or the combination of bridge priority and system MAC address is known as bridge ID or switch ID. So if I want to know these two things, how I will come to know? So if I'm coming to my switch, I'll say that okay, why this switch one has elected as a root switch? Okay, why not this switch 2? So if you will see the MAC address of switch 2 is this one. Sorry, is this one. Okay, so let me copy here and paste it. This is the MAC address. Let me come to switch 1, and this is the MAC address. Now if I'm coming to switch 1, and here is saying that priority. Okay, so the priority is this one for both the switches. If you'll come here, here is also same, priority is same. So if I'm coming to my switch, I'll say that priority. Okay, so all the Cisco switches priority will be same. So if you have any kind of Cisco switch, the priority will be 32768. Okay, so what is saying here, so if the priority is same here also, and here to another switch, second switch also. Okay, so you have to use second condition to match who will become root. Okay, so for matching is, you have to find which one is the lowest one, whether the priority or whether the MAC address. So if you'll see, the priority is 32768, priority is 32768, no one is lower, is equal, but MAC address is lower than, so switch 1 MAC address is lower than switch 2, so this switch 1 will be selected as a root switch. Okay, so you say here, if you want to check MAC address,
Hello, sir.
yes.
I would like to ask you something.
Okay, so now if you will run so a spanning tree, you will get switch priority and MAC address. But if you want to know from where you can get this MAC address from, so you can type this so version also. So if you're coming here, and if you are coming and typing so version will also give you the MAC address. I don't know why this. Okay, no problem. I have Cisco packet tracer. You should get it. Enable so version. Okay, see here, base Ethernet MAC address of this switch. Okay, so you type so version. So in the so version you can get only MAC address, but if you're typing this command, so spanning tree, in this you will get MAC address as well as your priority, MAC address and your priority. Okay, so bridge priority, what is your bridge priority? I told you that your root bridge, okay, whenever your root bridge will be elected, so root bridge is elected with the help of bridge ID, and bridge ID is the collection of bridge priority and MAC address. Okay, now so priority is same between all the switches, so they use MAC address to compare. Okay, so whoever have the lowest MAC address, that switch will become root switch. or whoever have the lowest priority, that will become root switch. So first they will compare priority and then they will compare MAC address. So here bridge priority is what? The default priority is 32768. Okay, and why it is 32768 we will come to know. Okay, and this is for all the it is for all the Cisco switches. By default the priority is same. The lowest priority will win to become a root switch, but if the priority is equal, or it is tie in the priority, so the lowest MAC address will be used as a tiebreaker. Okay, and that lowest MAC address will be compared, and then you will become as a root switch. Now in every LAN you will have only one root switch, and others will be considered as a non-root switch. But if you want, you can make primary root switch and secondary root switch, but that is a manual process, but we are talking here as a default process. Now root switch, all ports will be considered as a designated port, what we have seen. See, what is the meaning of root port? Root port means I want to reach root, so which port can forward my data faster to reach root port. But if I am root, for me, I don't need to find root. That's why on root switch you will not find any root port. Okay, so here is saying that root switch, all ports will be considered as a designated port. Lower value is preferred over high value. So if you are comparing any kind of information between two switches, okay, that who will become root or which port will become what, so in that case they always consider lower value. Lower is preferable, lower is more trustable, you can say, whether you are comparing um, any information. Okay, now the what we talked here, this is the default parameter to select the root switch. Okay, but if you want, you can change, you can manipulate in the switching root selection, port selections, like that. Now here, sometime in the interview somebody can ask that, okay, why the default priority is 32768. Okay, now I told you that the bridge priority is of 16 bit, MAC address is of 48 bit. Okay, so the total, your bridge ID, you can say, that is of 8 byte. Okay, now here it is saying that MAC address, we cannot change anything. This is the default MAC address, and which is already there in the switches. But how, sorry, MAC address, but how they are selecting bridge priority, and why the bridge priority is 32768. So by default bridge priority is 16 bit, and as if you have seen my IP address class, so in that we have calculated some bits to IP, right? So if I have 1 bit, what will be your value? If you have 2 bit, what will be your value? If you have 3 bit, what will be your value? So if you calculate here all the bits, right? So if you are talking about till 16 bit, okay, so 16 bit, if you will calculate 16 to the power, okay, 16 multiply by 2 to 2, like that. Okay, then you will see it is 32768. Like if we are talking about CL, 16 to the power, that one, think standard, not standard, scientific. 16 16, I don't know how to get those information. Standard 16 power okay. So remember we used to calculate this in our I okay. So if I have 8 bits, right? 0 1 2 3 4 5. Okay, so I should start from 0 instead of 1. Here I will change it. Okay, it's 0 1 2 3 4 5 6 7 8. So if you have 8 bit, then your this is your IP selection, right? You have 256 IP address. So if you have 16 bit, okay, what will be your decimal value? So it is 32768. That's why it is here. Okay, now can we modify these things? Can we change our priority? Yes. If we will select, by default it is 16 bit. If I will select 8 bit, okay, so I can change my priority. Okay, but priority changing we will see later on. Now verify root bridge election process in the below picture. Now the switch with the lowest MAC address will be the root bridge in the case of equal priority. So if you want to check priority plus MAC address, you can check with the show spanning tree command. But if we have this type of topology, how it is working? See here. Switch A priority is 100 and the MAC address is this one. Switch B priority is this one, MAC address is this. Switch C priority is this one, MAC address is this. Switch D priority is 100, MAC address is 55 something. Switch E MAC priority is this one, MAC address is this one. Now, so if you are comparing, so first comparing is priority, then MAC address. So whoever has the lowest one, switch A has the lowest one, and switch D has the lowest one. So this switch B will not participate in election. Switch C will not participate in election. Switch E will not participate in election. Now switch D and switch A will compare themselves that who will become root switch. Now they will compare priority 100, priority is 100 is equal. Now they will look for MAC address, lowest MAC address. So if you compare, so the lowest MAC address is of switch A. So switch A will be acting as a root switch. Very simple. Now this is little bit conditional information. So in root switch, all ports will be in designated port. Here will be DP, here will be DP. In non-root switch, will have only one root port. Other ports can be DP or block port. Okay, BLK. So these are non-root switches. All are non-root switches. So in non-root switches, if they have 10 interface, no problem. They can have only one root port. Other can be DP or block. But how many DP, how many block, we will see as per conditions. Now, root port and root port cannot be face to face. Means this cannot be root port and this cannot be root port. Okay, and DP cannot be DP like that. Okay, root port cannot be facing root port and DP cannot be facing root DP. Okay, so here you can have DP, okay, or DP. If you have DP here and DP here, so one can be DP and one can be BLK block. Now, so this is just informational concept. Okay, so what is the system extended ID? System extended ID came when this per VLAN STP concept came. Where is that? This one. this per VLAN STP key. Okay, now understand this one. So let me come here to this lab. I have this switching lab. Okay, I'm using layer 3 switch. Okay, here enable conf t, and then I am trying to create some VLAN 100, VLAN 500, VLAN 1000 is okay. I'm able to create, no problem. But when I'm trying to create VLAN 2000, okay, it is not supported. Okay, first problem. Okay, it is not supported. Now, why it is not supported? So if we'll come here and type so spanning tree summary, saying here, see here, by default, when you do not have system extended ID, okay, you cannot create more than where is that? Okay, see here. Okay, see the normal STP. Okay, what we are using. Okay, in that you can only create 1024. No, yes, 10100005 VLANs. But when you want to create more VLANs, so your system extended ID must be enabled to support more than 1005 VLANs. Okay, so if I want to create more VLANs, okay, till 4094, in that case I need to extend my system ID. Okay, so I want to increase my system ID. Okay, so if you will come here and you will see this, see here my system ID is disabled, that's why I was not able to create more than 1005 VLANs. Okay, but if you are coming here in GNS and if you are coming here switch 1 and if you are typing this command, so spanning tree summary, okay, you will see here your extended system ID is enabled. So when your extended system ID is enabled, in that case if you want, okay, you can come here, so not so conf t here VLAN 2500, and if you type here so VLAN brief, see your 2500 VLAN, your 2000 VLAN is there. Okay, so whenever you want to check whether my system, why my system is not supporting more than 1005 VLANs, so you will see that your system ID is disabled. So you can enable system ID. Okay, you can enable system ID in your switches in.
There is no need to create till this 4094.
No, if you like, suppose, see
If you want to maybe increase
yeah,
it up to this number, maybe.
no, see, listen. Okay,
But in real life, can we go up to this number?
uh, more than 4094?
Yes.
No, no.
Yeah.
Okay,
So this
see,
is the reason why.
yes, see if I'm coming here conf t, okay, now if you'll share VLAN 5000, okay, see, can you see this?
Yeah.
Okay,
Command rejected.
yes,
Bad list character. Yes.
yes. Now see, understand what is the concept here. Concept is saying here that if you want to create some VLAN which is known as extended VLAN, right?
Yes.
Okay, so extended VLAN can be created in your switches only when your switches are supporting this extended VLAN system
Extended.
ID, right?
Okay.
But if your
Yes.
switch is not supporting, like this switch, you'll see here, it was disabled earlier. I don't, okay. So if it is disabled, for example,
Yes.
okay, it will not support. Okay,
Yes. Yes.
now, but if it is disabled and I want to enable it, right? So with this command I can enable it. Which command? This command, spanning tree extend system ID. But always keep in mind here, it's something is written. Okay, first let's understand then. Okay, somewhere I have written it, means if it is enable, right, you cannot disable it. Okay,
Okay.
so suppose if I'm coming here, okay, so let me write that command first to show you.
Are you are you hearing your voice back?
No, now is okay. Now
Okay.
spanning tree, okay, spanning tree extend, spanning tree extend system ID, and if you click here, see, means this command is used to enable it, right?
Yes.
Okay, but you also know that if I will write no, no means to disable, right?
Yes.
Okay, so if I'm writing no, can you see the message what you are getting?
They do they do not accept it.
Yes, no spanning tree will not be accepted. Okay,
Yeah.
due to ex- due to
Enable you to
extended VLAN
extend it.
experience. Why extended
Okay.
VLAN experience? Now see, so a spanning tree. Can you see here? I have multiple VLANs.
Yes.
Okay, but if I'm taking one new switch, switch 3, just on this one, start and take a console. So spanning tree, you have single instance, right? Single
Yes.
instance,
Only
and if you are
keep it
typing
on
here, so spanning tree summaries.
extended.
See, this is in running, but if you'll see here
Yeah.
conf t, okay, spanning tree extend system ID, no. Okay, no message, no error message, right?
No
Now,
error there.
yes, but if you're checking here, so a spanning tree summary, okay, see here, no error message,
It's
right? But still it is
yes.
enabled.
Yes.
Okay, so I don't know why it is, but it should disable it. But what is saying that
Yeah.
the switch which support extended system ID, okay, you cannot disable it,
Okay.
but you can enable. Okay, now understand about some system ID.
Okay.
Concept of extended system ID. By default, if I'm using 802.1d, right? 1d, okay, which is our original standards. In that, we have two components for selecting our priority, right?
Yes.
Okay, so one is bridge priority and second one is MAC address. Okay,
Okay.
so with the help of this two, our bridge ID is considered, right? Or switch
Okay.
ID, okay, or root ID you can say. So this we have already seen 16-bit and this 48-bit MAC address. So you will find this priority same on all the switches, but MAC address is different. So according to MAC address, they are selecting who will be acting as a root bridge, right?
Bridge. Yes.
Okay. So by default, bridge ID is MAC address on all the switches, right? Because priority is same. So they compare with the MAC address. Now,
Okay.
as STP involved to operate on per VLAN basis. So if you are using STP normal, Normal STP means single instance for all VLANs. Then there is no problem. You will use this old technology. But
Okay.
as it is working as a per VLAN basis, a unique bridge ID, okay, became mandatory for each VLAN.
Okay.
Okay, this was originally accomplished by assigning a unique switch MAC address to the bridge ID for each VLAN. Okay, now, so this approach suffered from scalability issue, running that a switch support at least 1024 unique system MAC address. Okay, so if I'm coming here, see here, if we have multiple MAC address, multiple VLANs, okay, so your system priority is different. See here, 3 to,
Yes.
okay, let me start from 1. Okay, so a spanning tree. Now this is your priority. What is your default priority? 32768, right?
Yes.
Plus 1. Why plus 1? VLAN 1, right? VLAN
Okay.
1. That's why it is 32769.
Okay.
Now VLAN 10 means 32768 plus 10. 32768 plus 10 is 78, right?
Yes.
Now come here 20. So now this is different priority, right?
Okay.
For 30, it is different priority.
Okay.
For 40, it is different priority. 50, it is different priority. Okay. And now if I'm coming here conf t, okay, VLAN 4094, right?
Okay.
It is created.
The last one.
Yes. 4094. So what is your priority?
Okay. 3 6 something.
36. Okay.
Yes.
Okay. Now, so you are using all VLANs, means you are able to create all VLANs when your
Yes.
system is supporting extended system ID.
Okay.
Okay. Now, but if I am using default, means my system will not create unique MAC address, means your system is creating MAC address also. See here, if you will see here, okay. Now see, if this is the VLAN, right?
Yes.
Okay. So for each VLAN, if you'll come here and if you'll try that conf t interface VLAN 10, right? No shut. Okay. Now, so interface brief. Okay. So IP interface brief. So you'll see here uh, how I can get. Okay. So interface VLAN 10. Okay. See here. Your VLAN will have MAC address. See, this is VLAN 10, right? This is the MAC address,
Yes.
right? 100.
Yes.
Now, if I'm coming here, conf t interface VLAN, we have, do we have VLAN 200? Okay, VLAN 50 or 20. Okay, VLAN 20. Okay, shut, no shut. And now you check for VLAN 20. Okay, you will find some MAC address for this one also. Okay, why is it showing? C18. That is the hardware. This is the base MAC address, right?
Okay.
Okay, no problem. But first, you understand this one. is saying that whenever you will
Okay.
assign any VLAN, right? So switch will assign like your switch will assign a unique switch MAC address to the bridge ID. Okay, for each VLAN, right? Okay, no, it's not MAC address. Sorry, I was wrong. Okay, so this one. So a spanning tree, this one. Okay, see it.
Yeah,
Unique,
okay.
yeah, this
Okay.
one. 69. Now you will see something like what happened to the VLANs. So VLAN brief. Okay,
Did you create?
yes.
Huh?
I don't. Okay, no problem. Come to switch two. You can see here. Okay. So for VLAN 1 is different, for VLAN 2, 10 is different, for VLAN 20 is different, right? Okay. But it's saying that how long you can go. So you can go up to 1024, means your switch can only create or support at least 1024 unique system MAC addresses or unique system bridge ID for your switch. Okay.
Yes.
Now, now after 802.1q, okay, the these things has been changed, means the bridge ID to include an extended system ID which identifies the VLAN number of the STP instance, means we are creating multiple instance or switch like per VLAN STP. Okay, the bridge ID remains 64, no problem. Okay, the bridge ID is still 64. This one, it means the bridge
Yes.
ID 64. There is no problem in that one. But what they said okay, the bridge priority earlier it was sorry, it was 2 byte, but now they said okay, let's divide this 2 byte into two part. Okay, one is bridge priority
Okay.
and second one is system extended ID. After this, so your earlier it was, see here, earlier it was 16 bit. Okay, but now it
Yes.
is 4.
Divided into
Yeah,
in
4 and 12, means 4 is bridge priority and 16 is now system extended, or you can say VLAN ID, which is used for VLAN ID. And MAC address is same because there is no any changes in the MAC address. So what is saying that whenever you want to change, okay, you can change the priority, but can you change the MAC address?
no.
Suppose when we want to make some switches as root switch. Okay, so we have
Yeah.
two options to select: bridge priority and MAC address. So we say that okay,
Yes.
priority is same, so let's change the MAC address. So can we change the MAC address? No. So we
Yeah.
change, what we change, we change the priority,
The
right?
pirate.
Okay, so here is saying that that's why they made changes in priority instead of MAC address. Okay, now, so they borrowed 12 bit from the bridge priority, and the range is now altered, means supported range is now increased. The original priority range, okay, is 0 to 65,535, but in that we use 3 to 768. The with the because we were using 16 bit, right? Now
Okay.
with extended system ID, now the priority range, okay, the priority range is 61440, and the priority must be in the multiple of 4096,
Nice.
right? Now I'll show you one. Okay, so now he's saying that now you, let me show you something. So if I'm coming to this switch, okay, enable conf t spanning tree VLAN 1, okay, priority question mark. Can you see here? 61440 priority, right? Why? Because
Yes.
this switch is supporting,
And
you can see here conf,
extended.
yeah, extended system ID. Now you can conf t spanning tree VLAN 10 priority question mark. See, but if I'm coming to the switch who do not support system extended ID, let me check this
Okay.
newer switch. Oh, okay, now if I'm coming to this switch, enable, so spanning tree. Okay, now if I'm coming here, VLAN 10, VLAN 20, exit. Now if I'm coming here, so a spanning tree, see, VLAN 1. Can you see here? VLAN 1. But where
Okay.
is VLAN 10? See, VLAN 10 is there. So VLAN brief. VLAN 10 and VLAN 20 is there. But if I'm checking here, so spanning tree, okay, you have only single instance, right? So
Yes.
if you are trying to make this switch as a root switch, so see here, conf t spanning tree VLAN 1 priority. Okay, this one is also supporting. Is it this switch? Okay, no, priority should be 65,000. Earlier it was like this here. So the priority range was this one, but when the system extended ID came, so the priority came to 61440. Okay, and whenever you want to change the priority, so you cannot change the priority whatever you like. So you have to change the priority with the multiple of 4096.
Okay.
Okay, but when the system extended ID is there, okay, your priority will start from this one, default priority. Okay, but if you want you can change, but to anyone like 4096, like this one,
Okay.
like you can change to 4096 or this one or this one or this one. Okay, multiple of this 4096. Okay, now extended systems IDs are enabled by default, cannot be disabled. Okay,
Okay.
and cannot be disabled if a switch platform does not support 1024 system MAC address. It doesn't mean that if it is not supporting, okay, let me disable it. Means if maybe if you have lower platform of switches or something like that. Simply means if system ID is enabled, you cannot disable it. Okay, okay, and how to enable this one we have already seen. Now once this extended system ID will be increased, okay, and it will support the VLAN up to 4094.
Okay.
Okay. Now STP hello means STP, when STP send hello, so hello is sent by BPDU, right? So as we
Yes.
know that STP is a automatic process. By default, we no need to change anything regarding this BPDU or like STP because it's default. STP is enabled by default and will keep doing its functions continuously as routing protocol is using hello packets for their automatic route learning process. STP use BPDU as their hello packets to send and receive the information regarding route bridge, right? Route bridge election and port type decision, whether this port will be acting as a root port or designated port. Okay, now so BPDU are the hello packets of STP and it will be sent to other switches or exchange in every 2 seconds.
Okay.
And whenever BPDU will send any kind of message, they will use multicast MAC address, which is 0180 C200, like that. Root bridge is elected by the exchanging of BPDU message between the switches, and whoever have the better BPDU, means you have seen the conditions, right? That root, that
Yes.
switch will be elected as a root switch.
Root switcher.
BPDU used to do all the calculation for STP process. So BPDU do all those things like listening, learning, forwarding, root switch, designated port. All these things are done by BPDU. In STP process, BPDU are generated only by the root switch. STP process I'm talking. I'm not saying
Okay.
per VLAN STP, PVST, RSTP like that, right? Means if it is
Okay.
STP like this switch, in this switch, this one, where you have only single instance. So in that
Okay.
only this root switch will be able to generate BPDU. But when we are talking about per VLAN, STP and PVST, in that all the switches will generate BPDU message. Okay, and it will be multicast in every 2 seconds by the root switch in STP process. And you know the MAC address of this one. Other
Like
switches
yes.
will only receive BPDU in STP, right? But
Okay.
in RSTP, PVST, all switches will receive and all switches will send BPDU. Okay.
Okay.
Now we have some kind of BPDU types. Okay. So we have two type of BPDU. One is the BPDU is based on information what they have, and based on the bridge ID. Okay. So we have two type of information. Okay. Now see. So the BPDU is divided into two type of classification. One is based on information type and based on bridge ID. So first understand the bridge ID, okay, then information. So in the bridge ID, first they run bridge ID and they select who will be acting as a root switch, okay, and who will be acting as a non-root switch. Your port will be root port or designated port, right? Understood? Now, so there are two type of BPDU. One is superior BPDU and second one is inferior BPDU. Superior
Okay.
means whoever have the lowest bridge ID, that I will consider, like see I am switch and in my network I'm connected with 10 switch. So if
Okay.
I'm receiving multiple BPDU, so how I will know that okay this is better BPDU? With the help of comparing of bridge ID, right? So I will compare, okay,
Okay.
this one is the better BPDU. So with the help of better BPDU, I will be synchronizing with the root switch and then process will start, right? Inferior means the highest bridge ID. So highest bridge ID means that is bad BPDU,
Yeah.
right?
Yes.
Okay. Now once the BPDU has exchanged and the root switch, root port, designated port has been elected, after that there are two BPDU message will be running after
Okay.
those selection. One is configurational BPDU and second one is topology change notification. Configurational means after root port selection, right?
Okay.
Used to identify the root bridge, root port, designated port and blocking port. Means once I will select that okay this is the superior BPDU, right? So once the bridge is elected, after that root port, designated port, and those things configuration. Okay, suppose I
Okay.
have one switch here, this switch. Okay, I have this switch. Okay, so once the root switch is elected, so who is electing root port, designated port, block port? Means after root bridge selection, after better BPDU, there are some other configuration is sent via root switch. Okay, no, you make root port, you make block port, like that, like so these all information
Yes.
or configuration is sent by a root switch. Okay, so that is known as configurational BPDU. Now topology change notification, if any link is down, suppose this I have one switch here, and it is connected with another switch, and if this link is down, right? So
Yeah.
maybe it is connected like this. So I will inform to this switch that okay, this link is down, please go via this link or use this link,
Okay.
or and change your status, whether it is root port, change your status. Earlier it was designated and this link is down, so now change your status, because you will change the status also of your port, right?
Okay.
Okay, so this is known as topology change notification BPDU, and this will be sent to other switches when there will be changes in the topology. Okay, content of configurational BPDU: protocol ID, version, type field, flag. So these information will be there in the configurational BPDU. Okay, like BPDU type, flag, root identifier, cost to reach root. Okay, your bridge identifier means your ID. Okay, port ID means, switches has the port also, right? So every switch has some port ID, right? Can you see that? The port priority. So this is known as port ID. Okay, so these all informations will be travel in the configurational BPDU. Now content of topology change notification. So in that, protocol ID, version and type field, there is no nothing is there. Okay, so BPDU type, protocol version and protocol identifier, that's it. In that they will understand that there are some changes, so let me converge, and or you can say reconverge and find a new path to reach root. Okay, so again STP process will run.
Okay.
Now these are something to remember. Only one only root bridge can send the BPDU in the switching
Yes.
topology, or you can switch topology. Okay, but in which condition? In STP. See, right now we are only learning STP. Your PVST RSTP will come later. So okay, so we are learning STP, that's why these are only STP information. Okay, and you will find around 3 or 4 video related to STP. Okay,
Okay.
after that only enhancement is there. Okay, so that
Okay.
there will be like in one video or two video everything will be completed, like PVST plus and RSTP.
Okay. I see.
Now for the first time, all the switches in the network will send BPDU first time. Okay, and why
Yes.
first time they will send? Because first time everyone will think that I am root bridge, right?
Yes.
Okay, and with the help of BPDU they will compare themselves, that okay, and after comparing they will select okay that who is root bridge. Okay, once the root bridge is selected, now in the first BPDU they will add their designated bridge ID as the root bridge ID. Means in the switches, after exchanging, you can see here, let's come. Okay, once they will exchange the information, so spanning tree, they will add these informations, okay, like this. Okay, that who is root. Okay, see, there are two information, one is root ID information and bridge ID. So bridge ID information is your own switch information, and this root ID information is the root ID of the root switch, right?
The root switch, right?
Okay,
Okay.
so this uh, once each switch has sent BPDU to its other neighbor switches, and he has already received BPDU from the neighbor switches, they will compare themselves with their own bridge ID. Okay, with the other switch bridge ID, and the lowest bridge ID will be selected as the root bridge. This we already know. Okay, and all other switches will agree on this election. Why? Because they have compared the same thing as other switches has done. Now how to identify superior BPDU? So BPDU having the lowest bridge ID will be known as a superior BPDU. So now tell me, I have switch 1, switch 2, switch 3. Okay, so which switch has superior BPDU? Switch 1, switch 2, switch 3. Which one is sending superior BPDU in the network?
Um, one, two,
This
three.
one.
Yeah, this one.
So in the
No,
networks, this one has
yeah,
the superior BPDU. So this will be elected as the root
this
switch.
is
Okay.
root switch here.
Yes.
Exit 00A.
Yes. Now, if you are saying that, okay, if the bridge ID is same, okay.
Yes,
So if the bridge ID is same, they will compare with the MAC address, right?
yes,
Okay. Now in this case, it will check the lowest path cost. Okay. Lowest path cost. No, this will delete it. Okay. Okay. What is the cost? Okay. Sorry. What if the cost is also same? Okay. So this we will discuss. I think in this slide. Maybe I have changed the slide. Is is maybe okay? No problem. Okay.
okay,
Okay. So this will since what the if the cost is also same. Okay, because this is different. Okay. Now, so root bridge election we have seen already. Okay, no problem. Now root bridge election using BPDU. So these are some messages. Okay, so this is the BPDU one means message one from switch one. BPDU packet one from switch two. BPDU packet one from switch three. First they will send
yes,
bridge ID, root ID, link cost, interface. Right. Bridge ID means here
yes,
he will say that okay my bridge ID is 32768, right?
okay,
Okay. Root ID they will say that my MAC address. Okay.
okay,
Okay. So everyone will send the same. Everyone will send the same link cost. Okay, that one. You remember link cost 128.1. This one.
yes,
This one 128.1, 128.2 like that. Okay. And
okay,
interface number sorry link cost is 128 and interface number is 1 2 3 4 like that. Okay, so this will be the
okay,
raw BPDU message means everyone will generate the
okay,
same. Now
cool.
looking the bridge ID and root ID. Okay, so it is the combination of priority plus system extended ID, right? System extended plus MAC
Yeah.
address. See, earlier your
Mm-hmm.
root ID or bridge ID was priority plus MAC address, right? But now
Yes.
when you have system extended ID means per VLAN STP, now you have priority plus system ID plus MAC address.
Okay.
Okay. So now if you'll check the second condition, okay, this is the raw. Okay, in the second condition, see when the first BPDU message is sending, so everyone is sending 32768 plus MAC address,
Mm,
32768 plus MAC address, 32768 plus MAC address. Okay.
yes.
So bridge ID and root ID is the combination of MAC address and priority.
Application
So
priority.
okay, so say everyone is sending like that. Okay, no problem.
Okay.
This is the priority. The port ID is 128,
First
128,
check.
and 128. Port number is like this, like this, like this. So everyone is connected with fast Ethernet 0, fast Ethernet 0, fast Ethernet 0. So all
Yes.
number will be 1, number will be 1, number will be 1. So this is the first BPDU message sent by everyone. Now in the second condition, see everything will be changed. Okay, in the second one, see when this one is advertising through BPDU message, second BPDU message. This switch is saying my priority is this, MAC address is this, my priority is this, MAC address is this. Now see,
Yes.
my priority is this, my MAC address is this. So this is my, this is what? This is, see, root ID and bridge ID. Root ID
Yeah.
is the ID of root
And the
switch.
root
Bridge
switch,
ID
yes.
is the ID of my own. Okay.
Okay.
So this is what root ID. Okay. So instead of writing root
Yeah.
ID here, okay. So root ID is the ID of root, right?
The root
Bridge
bridge, yeah.
ID is my own ID.
Yes.
Okay. So if you come to the second say, so first switch is saying I am root. This is my root ID, means I am root, and this is my
Yes.
bridge ID. This one is saying,
Okay.
okay, this one is saying that this is my bridge ID, but I am not root. So
This
this
one,
this one is root.
the
This is
ID.
saying this is my bridge ID, but this one is
This
root.
one, the root ID.
Okay, this is the root ID. So like this, they will be sending via BPDU. And why these all switches are sending? Why? Because maybe if another switch is connecting here, so if I'm not directly connected to switch, so who will inform me that who is root?
Yes.
So
Your neighbor.
this, yeah, this switch 3 will inform me.
Yeah.
That's why nowadays each and every switches are sending BPDU message.
Okay.
Lab verification. See, this is the root ID, right?
Yes.
And this is the bridge ID. So bridge ID is local to the switch, and root ID is
Yes.
the ID of root switch.
Root bridge, yeah.
Okay, and if it is, you will find like this bridge is the root, means I am
The
root,
local one.
and yes, I am root, and this is my MAC address and priority, you can say. But if you will find nothing like this, then I am not root, right? And
Okay.
your MAC address and this will be different. If you will come here, see,
Yes.
root ID is different, you can see here, and bridge priority is different, right?
Yes.
So I am not
There's
root.
no message saying this is root.
Yes. But if you'll come to switch one, you will find that, see, this is root, means
Mhm.
information is same, right?
Yes.
Now selecting root port, the link directly connected to root switch or the sorted path to root switch will be elected as a root port, right? Okay.
Yes.
But when you learn more, you will say that, okay, see, if I'm directly connected, it doesn't mean that this port will be elected as a root port. Okay. So root
Yes.
port
Just
selection will,
like
yeah, selection will work on the behalf of cost. Okay.
okay.
So every non-root switch looks for the best path to reach root switch. Okay, root port
Yes.
will decide based on the following condition: what least cost to reach me, means if I want to reach root switch, so from which way the cost is the lowest one. So from this way 19, and from this way it is 38. So this one is
38
the lowest
years.
one. That's why they have selected it like that, right? But if it is from this
Okay.
side, it is 19, and from this side is 4 4. So my this DP
Mm.
will become as a root port, right?
Yes. Yes.
Lowest forwarding switch ID. This we will see later on. First, because we are talking about root, so we have already
Yes.
selected. Okay. Now for every non-root switch, there is only one root port. Of course, yes. If I am non-root, I have only one root port. I cannot have multiple root ports in one switch.
Yes.
Okay. Now,
Okay.
if I want to check these information, you can run this command. So, a spanning tree, you will come to know. Yes, of course.
Okay.
If I'm running this command, I can come to know. See here. Okay, root
Okay.
port, block port, working port, or everything you will come to know, right? Designated port
Yes.
and like that. Now, root port identification. Root bridge ID will advertise BPDU with a path cost 0. Means, see this. If this route is advertising about this path, right?
Yes.
Okay. So this route will say that to reach me, right? To reach
Okay.
me, the distance is 0.
Zero.
That's why I will say, okay, the distance is 0, means you are route. Are you understanding?
Okay.
Like suppose I will say that I want to reach uh, Cameroon. So you'll say that, sir, to
Okay.
reach Cameroon is just 1 kilometer. Okay, and then I
Yes.
will ask, okay, and where are you? So you will say that, sir, I am just 1 kilometer far from you. Means you are in Cameroon, right?
Yes.
So here is saying that to reach me is 0. means then this switch will say that okay,
This the root.
it
It.
means you are the root. But if this switch is informing this switch to
Okay.
reach root, is 19. See, from
Yes.
me is 19, means from me is 19 means same like remember about EIGRP path calculation, remember metric
Yes.
calculation.
Yes. Metric
Yes,
calculation.
so here is this is saying that from me to root is 19,
Yes.
then this will inform to him. So he will say okay, you said from you to root is 19. Okay, I understood this one. Okay,
Mm-hmm.
to you to root is 19, but if I want to reach you is 19, so total is 38.
Yes.
Okay, so like this they calculate. Now
Okay.
as a downstream switch receive these BPDU, they will add the path cost of the receiving port. Yes, they add the path cost after receiving from another switch. Now
Okay.
the port with the lowest root path cost will be elected as a root port. Of course, whoever have the
Okay.
lowest cost to reach root, that will be elected
Root
as a
is.
root port. Okay.
Okay.
Now the comparing and the cost selection works on the behalf of this.
Okay.
Like, see, so there are two type of cost calculation. One is sort method and second one is
One is
long
long.
method. But now you will say that right now our switches are using long method or sort method. So if you come here,
So,
our switches are using shortest method. So if you come
yes.
here, switch 1, I did um, so if you are coming to switch 2 and switch 3, let me connect switch 2 and switch 3 also. So if I came to switch 3,
Okay.
what I am explaining, forget. Okay, cost.
Because yes.
Okay, so if you are typing here, so spanning tree, okay, can you see here cost 200, okay,
Yes.
but if you are coming to switch, cost is 100, right? But if you
Okay.
are coming to switch 1 for VLAN 1, there is no any cost. Are you understanding?
Okay. Yeah. It
Yes,
means zero.
yes, there is no cost. So they are calculating cost 100, but why cost 100? Okay, cost
Yeah.
100. Why not 19? Are you understanding?
Yes.
Okay, so if you see
But
here, see, cost 100 because I'm using Ethernet. If you check my
internet.
yeah lab, this is Ethernet. I'm not using fast
Yes.
Ethernet or something. But
First.
if you'll come here, this one, this one is using fast Ethernet, right? So if you'll check here
Yeah.
cost,
19.
yes. So spanning tree, then if you'll see the cost is 19, right?
Yes.
Yes. Okay. But this thing was okay till here, no problem.
Okay.
Okay, but nowadays when the 5G came, now you have 100 Gbps 1 TB, like these are speeds in the network nowadays. Okay, but if
Okay.
you are
With the
using
factor.
this shortest method, right, so the all cost is same for all the shortest method, right? The higher speed is also.
Yes.
So if you, in the future if 40 Tbps will come, or forget about this 20, if
Mm.
40 Gbps 50 Gbps, all the cost will be same. So the what is the benefit of speed?
Yes.
Okay, so we can use this long method, but you have how
Okay.
it will support long method. So you have to run this command to support long method. Okay, so let's come here.
Yeah. Of course, method. No.
So here, see right now, switch 3 is supporting short method, right? This one, shortest
Yes.
method, 200. But if I'll come here, conf t, spanning tree, uh, cost, no, path cost,
Path,
path
yeah.
cost, okay, question mark,
Long.
see, method, okay, then you'll see long and short. So right now I'm using short
Yes.
method, but if I will write long,
System.
okay, and now if you are typing here, so spanning tree, now can you see here?
Okay. Yes.
Okay, but for better understanding, see, here I'm using short and here I'm using long,
Okay.
so I'll get confused. So here I will also come and I will say that conf t spanning tree path cost method long, and then I will type here, so spanning tree, and then here I will be using this one, right?
Okay. Let's see.
Okay. Now one more thing to understand, command to this one, it's okay. The cost of the link is added while it is sending the information. Okay, it's okay, this is okay. By default fast ethernet is using 19. Okay, and cost 0 will be sent by the root switch, right?
Yes.
Okay, and if you'll see these information, you remember why the cost is like this, because this message what you are getting here is, this message is regarding BPDU. So when this message is
Okay.
sent to another switch, they add the cost. Okay, like
Okay.
suppose
So
if I'm,
now,
yeah,
how did they do to get this 2000 or 2000
20,000.
and 2000 for the cost, the long cost that we are talking about? How
Is
did
it
they
2,000,
calculate to get
20,000?
this? Is 20,000 or 200,000 something?
Yeah, it is there, man. Here, see, for 10 Mbps, the cost is like this. For 100
Yeah,
Mbps,
this one is 2 million.
yes,
Eh,
it's not 20, it's 2 something, 2 million like that. Yeah.
yeah,
So
the
this is
first one is 2
predefined.
million.
This is predefined, but
Okay.
if you want, you can change. Whenever you will change the
Okay.
speed of your link cost, it will change.
Yeah, it will change.
Yes.
So nowadays, which one did some company are using? I'm talking
Long
about the
one,
cable.
long
The
one.
cable.
Cable.
Yes.
So depending on the switch, suppose my switch is supporting Ethernet, so I have to use Ethernet. If my switch is
Okay.
supporting fast Ethernet, like suppose I have one switch, okay, let
Yes.
me bring it here. Let me connect this switch. See, this switch is supporting a gigabit,
Yeah,
right?
gigabit. Yes.
Yes. So this switch cost will be different, right?
Yes. I'm gonna be one.
Okay, and if you want to use this switch, so this switch you need at least 16 GB RAM to use this switch, because this switch is very,
Okay.
yeah, it will make your system slow.
Okay.
See, it still is saying booting. Can you see here? Is
Yes, I
booting.
can see. It's taking time.
Yes.
Okay.
Just I wanted to show you something like enable. So
Yeah.
spanning tree.
Okay.
Okay. See, this is the root. Why? Because it is not communicating to other
It's
switch
not
in the network, because
participating.
this one is gigabit and other one is that one. Okay.
Okay.
So gigabit cost is what? 4. See here.
So,
Let me stop this one. Okay. Now the default cost value of the links are based on the operating speed of the link. Okay, not the maximum speed. Like if this link is supporting 10 Mbps or maybe 100
yes.
Mbps or 1 Gbps, right? So if I will come
Okay.
to the link and I will maybe I'm using fast Ethernet, right?
Yes.
Okay, and I will make it speed 100. Okay,
Okay.
so speed 100 means I made this link to work as a work like
Ethernet.
what, like Ethernet, right? But it will
Yes,
not
yes.
work like Ethernet. Only
Yeah.
my cost will be changed, but my speed will be working like that.
Okay.
Okay, so if I'm coming here, if it will there, I can show you. Conf interface f a0/1 speed 100. See, not here. No, it has, no, no, sorry, I mean to say something. Okay, no, your cost will be same, your cost will never change, okay, because your link,
Okay.
yeah, but your speed will
Because
be
it's a
changed.
matter of cable. Yeah, it's a
Yes,
matter of cable too.
yes, yes. Okay, now root bridge and root port election. Okay, you can check here. Okay, or you can do this lab. Okay, so this, suppose this is the root switch, so root switch, all the port will be DP. Okay,
Yes.
this is non-root, this is non-root, this is non-root and non-root. Okay, so as this is a
Yes.
Ethernet, so Ethernet use cost 100, cost 100,
Yes.
cost 100, cost 100. Here is cost 100. Okay, so if this switch wants to root to reach root, right? Okay,
Yes.
so this switch can reach from like this, switch 4, switch 3, then root, right? Or this can
Yes.
come to switch 4, switch 2, or switch 1.
Same cost.
Yes.
Yeah.
Now, but how it will work now, see, after DP selection, once the DP is selected, designated port on the root. Now see, after that we are talking about root port.
Okay.
See, so this switch is directly connected, or you will see that, okay, if I'm directly connected, okay, so first condition is directly connected, right? Okay, and then second
Yes.
is cost.
Yes.
So cost is also same on all the links. Then I will consider, I will select the cost calculation, that okay, from this side is 100 and other is higher, so this is the root port.
Yes.
So
Okay.
after root port, the other port will become DP. Same here,
Okay.
after root port, other port will become DP. Here I have
Okay.
three port. Okay,
Okay.
so if I am trying to reach from this side and I'm trying to reach from this side, so I'm reachable from both side, and the distance is
Yes.
equal from both side. Are you understanding?
Yes. Yes. Yes.
Okay, but why I'm communicating via this side, not via this side? Because the MAC address of this switch is 003, 003,
Yes.
and from this side MAC address is 002. So I
Two.
will consider the lowest MAC address to reach root.
Okay.
Okay, and then this will become root. Okay, then after I have two port remaining, this one and this one, right? Now
Yes.
I cannot block this one, so if I will block this one, so I'll not be able to communicate to this one, right? That's why
Okay.
your this port is in block. Why block? Because this is your RP, right?
Yes.
For example, this is your RP and this is your DP, right?
Okay.
Designated, and this is your designated, right?
Okay.
First time. Okay, this is your designated. Okay, this is your designated. Root port is okay. This is your designated and this is your designated. So I said you
Mhm.
cannot have designated, no designated working together, right?
Yes. Yes.
Okay, now, so who will become block? This one or this one? Okay, what is the MAC address? 003.
Three.
This is 004. Switch 4.
Yes.
So switch 3 will say, please off your port because I am greater than you. So I will off myself.
Okay.
Okay, now here I am DP. Here
Yes.
I am RP, and then there is no problem.
Okay.
Okay. Root switch, designated, root port, block port, we have seen it. You can also compare and check.
So it means that if you have a switch which has three interfaces,
Yeah.
it means that we do.
We can have
It's
multiple
not.
designated.
Okay. My
Yeah,
question is that whether two ports in the same this one in the same switch
let me
can be
show you. Let me show.
a
I clear it.
designated port.
See. This is what.
Root.
This is root switch.
Yes.
Designated. All ports are designated, right?
Yes.
This is
Also
what.
a designated
This is non-root, right?
non-root.
Okay. One port is root. Okay.
Root.
Now see. Here is DP, right?
Yes.
So
Yes.
here is RP.
Happy.
Here is
Yes.
DP. DP cannot be same. Okay. So they will
Yeah.
compare. So he will say my MAC address is better. So I will off.
Okay.
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 Now see.
Yes.
Here is DP. Here is DP. DP.
Yes.
DP. Right?
Okay. Okay.
Okay. Now see. Here is DP. Here is also
Yes.
DP. 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 Here is also all DP. Right?
Yes.
Now see. In front of DP,
Yeah. We have root.
RP. No problem. In front of
Yes.
DP, here is except RP, all port will become DP first, and then they will compare
Okay.
and then they will block.
Okay.
Now see, I am DP. Okay, whose MAC
Okay.
address is lower? Root MAC address is lower,
Root
so I will
market. Yes.
block
Yes.
this one, right? Okay, now let's
Okay.
compare with this link and this link. Okay, I am
Okay.
DP, I am DP, I am DP, I am DP. Let's compare the
Okay.
MAC address. I am switch 3, you are switch 2. Okay,
Okay.
so my MAC address is 003, your MAC address is 002. So my MAC address is higher. So let me block.
Okay.
Okay. Now why this port is not blocked? Why? Because my MAC address is 003 and your MAC address is 004. So my this is my DP, this is my DP.
Okay.
Okay. And always keep in mind I can have multiple DP, but
In the
RP
same
can
list.
have only one.
Okay.
I can have multiple block, multiple DP, no problem.
Okay.
Okay. Any question in this?
Okay.
Why this
It's
port
okay.
is blocked?
Yes. Because it's facing GP.
See, to reach from this switch, okay,
Yes.
okay, which link is uh, best to reach root? This link
Yeah. F0
21.
slash next one here.
Yeah, not 22. Why? Because this is lowest. Okay, I will see
Yes.
this one. This is 21 is the lowest one. Okay, so
Okay.
that's why this link is my root. Okay, after that
Okay.
DP all is blocked. Why? Because everyone MAC address is lower than me. That's why my all ports are blocked. Even this one is also
Okay.
blocked. See how many blocks. This switch 4. Only one port
Yeah.
is
Fine.
root port. Others are 5
Yeah.
are blocked. Why? Because
Yes.
I'm the lowest one. Means
True.
sorry, my MAC address is highest. Okay, as
Yes.
compared with others. Okay, so we have seen this one also. This we have already
Yes.
seen. Okay, if you want to change, you can change the cost per VLAN also. Okay, we
Okay.
have seen the designated port. Okay, how the designated ports are elected, how the root ports are elected. Okay, designated port identification topology. You see the whatever you find the topology in this slide in the book. Okay, you
Yes.
do those labs and understand why this one
Okay.
is that. Okay, and you know that with the
Okay.
command. Okay, with the help of this command, so a spanning tree you can know the
That's
port
fine too.
roles and status, right?
Okay.
Okay, now notice the link between switch 4 and switch 5. See this switch 4 and switch 5. We will have to notice this one because others is okay, right? If you will
Yes.
compare this, let's see, priority 100. Remember this lab we have already discussed. Priority
Yeah,
100.
we
Yes,
discussed about it already.
yes. Now if you will see this, both port on this segment are eligible to become designated. So first they will become designated, right?
Yes.
Okay. Now
And then we can
STP will
provide the market
recognize,
as
yeah, recognize that there is loop because all both is DP, right?
yes.
Now, so on sorry, one of the port must be elected as DP and other side must be
Yeah, it
blocked
must be
because
blocked.
DP cannot be same, right?
Yes.
Okay. To block, they will compare themselves and they will compare themselves with the
The
switch.
priority first.
Yeah, switch priority. So whoever had the highest and lowest, so this one is the lowest one, this is the highest one, that's why my port is blocked. Okay,
Yes.
simple. They will compare with the, okay,
Okay.
port id to become our. Okay, now we will compare about some other examples. Okay, tomorrow, that
Okay.
okay, if my switch is connected with, see here I can understand because I have single link, right? But if my both link is connected to switch,
Yes.
right, if my both link is connected to same switch, so I can understand that okay, this is root, right? This is root. Okay, so designated, no problem. Okay, and this is root, right? This is root port, and this is designated port. But why this is designated, why not this one? Why not this one is RP? Okay, do you have any idea? Hello.
Here,
Yes.
the designated port is 01 and the other one is 02.
Yes, now see, in this condition, okay, they compare with port number.
Designated. Yes.
Port number, see, this port,
The
port id,
lowest one.
that's why it's written port id. See which port is lowest.
Yes.
Okay.
The top one. Zero
Yes,
one.
now suppose if here is gig 10, okay, instead of gig 1 it is gig 10. Now tell me which one will become root.
The same one?
Yes, why? Because see, if you are gig 10, gig 20, no problem. My
Yeah.
upcoming, my upstream switch port is
Yes.
what, 1 or 2? So this is 1, of
One.
course I am 10, doesn't matter.
Yes.
Okay, but see, if my switch is connected in this type of topology, instead of having like that, if this is 10, okay,
Yes.
and this is 2, so
Yes.
in this
So the two one.
condition, it will, this one will become root port, and
Root
this
port
one
and
will
the top
become
one.
designated.
Block.
Okay, can I
Block.
show you or you can understand it?
Block one. The top one should be the block one.
No, I'm saying, can I show you the practical or it's okay for you?
Okay, if you can show me speed.
Okay, no problem. So let me come here. See, right now it is working like that, right?
Yes.
Okay, so you can see here, this is DP, this is DP, fine, this
DP.
is RP, and this is block, right?
Yes.
No problem. But if what I will do, I'll come here, delete this link and delete this, right? Instead of manual linking process, I'm going to select here what I said, fast 10, right? Fast 10 to
Yes. 10.
uh, fast 10 to 1,
01.
and here I said fast 2 to fast 2, right? Okay, now you see,
Okay.
let me start. Now see, can you see here? Now this one is block and this one
Yeah,
is
I can see.
okay. So the
Yes.
selection is not local. Are you understanding? The port
Yeah.
selection is
Depends
always
on
always from
the
upstream switch, okay, not locally.
switch.
Okay,
Yes. Okay.
so don't think that the selection of the switches port depends on the local port id. If, see, uh, the route is same, okay, so why
Yes.
this port is block? Okay, why not this one? Okay, because my upstream
Yes.
switch port id
Yes.
is
Yeah.
is lower, that's why this is the route. Okay,
Okay. Yes.
so this one was we were
This,
talking here.
yeah, this one I remember you explained to
Okay,
me in Douala.
okay, so we have seen this condition, that okay, I can understand that my port is blocked, because my root switch is far from me and I'm connected uh,
Yes.
via different links, right?
Yes.
Yes. But here if you see that I'm connected to root switch, okay, with two links. So which link will
Rulings.
be blocked? So we have seen this condition, right?
Yes.
Okay. So now which port will become the root port on switch B? So we have seen and we have talked about these all things, right? Okay.
Yes. Yes.
See, MAC address is same. Okay. So in that condition, link priority will be
Mm.
used for the blocking RPDP selection, right?
Yes.
Okay. Now, so if we are comparing this one, that okay, you said that uh, if the topology is like that, switch, switch, okay, but maybe if you will find some kind of topology with in the middle
Mm.
you will find hub. Can you find any topology like
Yes.
this? You are
Yes, boss.
maybe you can find it, right?
Yes.
Okay,
Yes.
okay. So in this condition also, see here, this switch is sending like that,
Okay.
okay, single, okay. From this is
Okay.
also coming. So in that condition, right? Okay, you can,
Rulings.
yeah, you can change from this switch. So it in this
Okay.
condition it will work locally. So okay,
Okay.
now
Okay. I see.
yes, so I think we can make this topology, but you will not find these kinds of topology nowadays. Who is using hub nowadays?
Yeah.
But
Nowadays,
yes,
yes. This is the tool.
okay, okay, points to remember. Okay, port priority. So changing the port priority, we can see tomorrow. Okay, how we can change, modify the port priority and other options, right? Okay.
Yes. Okay.